Hey, good morning, Lorenzo. How's y'all's English class? Well, it would have been way worse if I was teaching the English class. Trust me. Um, that was not. I didn't mind writing papers for English, but if it had, or reading, I didn't mind reading or writing papers. But if it had anything to do with spelling or grammar, diagramming a sentence, or analyzing, I did not like analyzing literature. What do you think so and so is trying to get? I don't care. It's a good story. Leave me alone. Oh man. Um, but I love reading. I love reading. And I didn't love it, but I was good at writing papers. But anything else, no, no, no. Anyways, um, so announcements. Um, I'm in the process of finishing grading the exam two. We'll get that. It'll be done, and we'll be going over it briefly on Wednesday. I don't see a real big need to, at this point, to go over it in depth because in the grading process, everybody's doing really good so far. So, looking forward to good scores on exam two. Um, this week is kind of wrapping up our graphing sections. Um, make sure that you watch the lecture videos for assignment 15 before Wednesday, um, as Wednesday will be spent talking about how to graph polynomial functions, functions that have multiple turning points. They can go up, down, up, down, up, down. You know, they can do all sorts of things. This assignment right here is gearing us up for that. And then on Friday, we're going to talk about how to graph rational functions. I preserved 2 days for that lesson, so Friday and Monday of next week. We'll see if we need to use the Monday of next week. We'll just see how Friday goes. Um, so, today is all about assignment 14, roots of polynomials. We spent most of last class answering homework questions, so let's just go ahead and get started. And um, who's going to attract me? Is it Lucero?
Yes.
Good luck with your not track meet, but cross country meet. Good luck with that, and um, I I suppose that you'll catch up any missed notes or missed homework problems from your fellow classmates. Um, so good luck to you, and let's just go ahead and get started. What can we do? What can we look at? What questions are we dealing with in assignment 14?
Number 6.
Number 6. Problem number 6. We have f of x is equal to x to the third plus a 4x squared minus 3x minus 6, and list all the possible rational zeros and then use synthetic division to find an actual zero. So, did you find the possible rational zeros?
No.
Okay. Do you know how to find the possible rational zeros?
Yes.
Okay. So let's go through and do this together. Factors of your constant, so that's going to be negative 6, divided by the factors of your leading coefficient, which is going to be 1. And anytime my leading coefficient is 1, this makes this list of possible rational zeros really easy. So all we're going to do is list up the factors of 6. Since they're all being divided by 1, that's just going to be the factor of 6. So we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Alright, so these are the possible rational zeros, so that's part of your answer. The next thing that we want to do is we want to begin looking for an actual zero of the function. So I call this the testing phase. We're going to be testing these possible rational zeros to find an actual zero. So start systematically. Start with the 1. And we're going to use synthetic division. So the coefficients of my polynomial function are 1, 4, negative 3, and negative 6. And we're going to use synthetic division, so bring down the 1. 1 times 1 is 1, add, you get 5. Times 5, or times 1 is 5, add, you get 2. Multiply, you get 2, add, you get negative 4. That is not equal to 0. So this means that x equal to 1 is not a zero of this function. Alright, so no worries. Let's just keep going. Again, do this systematically. So I'm not going to go to 2. I'm just going to go back to the next possible rational zero, which would be negative 1. So 1, 4, let's move that down a little bit. X equals negative 1. 1, 4, negative 3, negative 6. Bring down the 1. And we're multiplying by negative 1. So 1 times negative 1 is a negative 1. Add, you get 3. Times negative 1 is a negative 3. Add, you get a negative 6. Times negative 1 is a positive 6. Add, and we get 0. Yay! This is exciting. We just found a zero of our function. So I'm going to circle this. Now, I always like to think about what this means. Not only does this mean that x equal to negative 1 is a zero of our function, but it also means that x plus 1 is a factor of f of x. And so this means that you can rewrite f of x now as x plus 1 times, now recall that these numbers down here represent the coefficients of our quotient, which is going to be x squared plus 3x minus 6. Okay. This is something I like to keep in mind. I like to be thinking about. I may not have to write it down every single time, but I like to keep this in mind. But we still need to find another zero of the function. Now, once I get to a quadratic equation, I abandon the synthetic division because, first of all, you don't know if any of these will work, and it may take you a long time to find an actual one that works. So I just abandon the synthetic division, and I go straight to the solving process. My first thought is going to be, does this factor? Are there factors of c, which is a negative 6, that sum to b, which is a 3, and no, there are not. So it doesn't factor, so you can either use completing the square or the quadratic formula. Since this is odd, I don't want to have to do completing the square because that's going to involve fractions. If it was even, I would probably complete the square, but since it's not, we're going to use the quadratic formula. So identify your a, b, and c. Now let's go through and plug things into the quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is negative 6, all over 2 times a. So we get negative 3 plus or minus the square root of 9 plus 24, all over 2. So it's going to be negative 3 plus or minus the square root of 33, all over 4. Now, I would ask myself, could I simplify the square root of 33 and it's not over 4, it's over 2. Could I simplify the square root of 33? And the answer is no. There are no perfect squares that divide nicely into 33, so this is our other 0, or other zeros of our function. So we already had x equals negative 1. We found that by synthetic division. We found our other two zeros by using quadratic formula, so I'll say that the zeros of f of x are x equal to 1, x equal to negative 3 minus the square root of 33 over 2, and x is equal to negative 3 plus the square root of 33, all over 2. Does that make sense? Alright, what else can we look at?
Number 2.
Number 2, list the possible rational zeros of f of x is equal to 3x to the 4th minus 11x to the 3rd minus x squared plus 19x plus 6. Alright, so the possible rational zeros, I'm going to ask you some questions. Factors of what over the factors of what? What goes on top? 6, the constant. Good. And on the bottom? 3. Question. Alright. A young lady sitting in the middle with the purple shirt. What's your name?
Ariel.
Ariel? Alright. I'm just curiosity. You held up 3 like this. Did you learn to count like that?
No,
No, you
I
just
just thought it was easier to see. I don't know why.
okay. I was just curious. I was like, that's interesting. I was like, did she learn to count a different way? My son, I'm teaching him 1, 2, 3, 4, 5. I mean, he can already count to almost 20. He gets his teens mixed up, but I'm wondering if I should have taught him to count like this: 1 with a thumb, 2, 3, 4, 5. I mean, we learned it in America, I guess. 1, 2, 3, 4, 5, like that. But I think in Europe they go 1, 2, 3, 4, 5. Anyway, but when I saw that, I was like, that's interesting. Anyways, all right, let's get back to work. Let's get back to work. All right. So what are the factors of 6? Plus or minus 1, 2, and 3, and don't forget 6. And factors of 3 are 1 and 3. So what you have to do here is you have to think about taking 1. You can, I think I'll do it like this: 1 divided by 1, 2 divided by 1, 3 divided by 1, 6 divided by 1. So let's start there. That's really easy because all you're doing is divided by 1. So you got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And then you got to go through and do everything divided by 3. 1 divided by 3, 2 divided by 3, 3 divided by 3, 6 divided by 3.
Bye, Mr. Compton.
I'm sorry, what? Oh, bye. Bye-bye. Good luck. So 1 divided by 3 is a third. 2 divided by 3 is 2/3. Now 3 divided by 3 is 1. Well, we've already written 1 over here, so I don't have to write it again. And 6 divided by 3 is 2. Well, I've already written 2 over here. I don't have to write it again. Done. All right, what else can we look at?
Number 11.
Number 11. All right. Question. Have you found the possible rational zeros?
What did you ask?
Have you found the possible rational zeros?
No, sir.
Go ahead and find those. Tell me what you get.
Woo. I found them.
What are they?
There's a plus and minus 1, a plus and minus 2. Oh, wait, not 2. Plus and minus 3, plus and minus 5, plus and minus 15.
Good. Now, we're going to start the testing phase. And we'll start off with x equals 1. Now, again, I'm going to ask you this question. What are the numbers that I put up here, this first row? What numbers have I put right there?
1, negative 2, negative... Oh, the zeros.
Good. Good. I was testing you and you passed. Good, because there is a 0x to the third right there. Good. So we have 1, 0, negative 2, negative 16, negative 15. All right. Do it. And tell me what you get.
That you'll end up with like a negative 32.
So bring down the 1.
Sir, you put a 0. It's a 1. Cause you add the 0 plus 1. That'd be a 1. 1 times 1 is 1.
Indeed. Indeed. Yeah. Which is, I mean, for all intents and purposes, it's not equal to 0. Alright, so 1 didn't work. What about negative 1?
It works. It equals 0.
Good. Alright, so I'm not going to go through and do that, but you're right, it does work. So we have, actually, let's just go ahead and do this real quickly because we need these coefficients. 1, negative 1, negative 1, 1, negative 1, 1, negative 15. There we go. Alright, we need those coefficients. So, what you have from these coefficients right here is you have an x to the third minus an x squared minus an x minus a 15. This is not going to factor by grouping. And we don't have any other way to solve this, so we got to keep going with synthetic division. I don't even know what I was trying to write. Alright. Now, we're in a nice group setting, so let's divide and conquer, because there is no guarantee. So if you, never mind. Let's do 3. It's the next possible rational 0. Let's just do 3. X equal to 3. Why don't y'all go ahead and get started on this one? Maybe we'll meet in the middle. Did you get it? Alright, so 3 is a 0. So, what we now have, 1, 2, 5, I'm going to go to my next page. We now have, behave iPad. 1, 2, 5, so that means that we have x squared plus a 2x plus 5, set it equal to 0. What are the factors of 5 that make it 2? Well, that's not going to work. This is not going to factor. So we need to solve this. Again, your options are using the quadratic formula, or you can complete the square. And to shake things up a little bit, I'm going to solve by completing the square, because I think it's a good thing to remember. So, start off by subtracting the 5. And then we want to do this b over 2 quantity squared. What is b? It's 2, so 2 over 2 quantity squared is equal to 1 squared, which is equal to 1. So we're going to add 1 to both sides of our equation. Now, this is going to factor to x plus 1 quantity squared. Then you get negative 4, and now we get to solve by the square root method. So I'm going to square root both sides, but anytime that you square root both sides, make sure to include the plus or minus notation. So you get x plus 1 is equal to plus or minus square root of negative 4 is 2i. Isolate the x by subtracting 1 on both sides, so you get negative 1 plus or minus 2i. And there are our other zeros of f of x. So, going back from the previous page, the zeros of f of x, I believe we got x equals negative 1, x equals 3, and now we have x is equal to negative 1 plus or minus 2i. Make sense? What else can we look at?
That's all we have for 14.
That's it? Okay. So are y'all finished with the assignment then? 1, 2, 3. All right. Cool. Well, let's talk about where things are going. I'm going to give you, have y'all watched the notes for assignment 15 yet? No? I'm going to give you a preview.
I'm in the middle of them.
You're in the middle of them? I'm going to give you a preview of assignment 15. I'm going to give you a condensed preview. All right. Preview of assignment 15.
Can you change the screen?
Yes, that would be a good thing to do. Graphing polynomials. All right. Example 1. Graph x to the third plus an 8x squared plus a 15x. So, the first thing that you wanted to do is you want to determine what's called the end behavior. And there's 4 different end behaviors that you can deal with. You could have end behavior, you have opposite end behavior, where the graph would fall on the left and it's going to do something in the middle and rise on the right. So you see it's falling on one side, rising on the other side, or it could do something like this, where it rises on the left, falls on the right. Or you can have the same end behavior, where what it's doing on the left is the same thing on the right. Now, opposite end behavior is when your n is odd. And the same end behavior is when n is even. And the n that we're talking about, I'll highlight this, the n that we're talking about is going to be the leading exponent of your function. So just by looking at my function, since 3 is odd, hold on just a second. Hold on. Okay. Sorry. Odd. Now, we know that the end behavior is going to be opposite end behavior, but what's it going to be? Is it going to be this or is it going to be this? Well, this is when your a sub n is greater than 0, and this is when your a sub n is less than 0. And what is a sub n? A sub n is the leading coefficient. A sub n is that leading coefficient, what you have right here. So I'm just going to highlight that. So for us, we have a 1, which is positive. So we can tell that our end behavior for this function, since our exponent is odd and our leading coefficient is positive, that we have this end behavior like this, where it falls, I'm going to write this out, falls on the left and it rises on the right. Now, similar thing over here. If a sub n is greater than 0, you have the same end behavior. It's going up on both sides. And here, if a sub n is less than 0, it's going down on both sides. So we know stuff about end behavior. I'll just highlight this. Now, the next steps really aren't in any particular order. B, what are the zeros of the function? To find the zeros, you're going to set f of x equal to 0 and solve. So, I have x to the third plus an 8x squared plus a 15x equal to 0. And the first thing I recognize is that I have a GC of x. Excuse me. I can factor out an x. And I can continue to factor because what are the factors of 15 that make an 8? How about a positive 3 and a positive 5? So now that this is completely factored, I can set each factor equal to 0. Which then means I get x is equal to 0, x is equal to negative 3, and x is equal to negative 5. So there are the zeros. Another word for zeros, or another interpretation, are the x-intercepts. The zeros of a function are where the graph crosses the x-axis. C, we want to find the y-intercept. To find the y-intercept, we're going to evaluate f at 0. So f at 0, plug in 0 into your original function up here and you get 0. So we have a y-intercept at 0, 0. And little heads up, if you have an x-intercept at 0, you have a y-intercept at 0. Now, for the sake of time, one of the things I talk about in the notes that I'm not going to talk about in this particular example are multiplicities. Maybe we get to one before the end of class today, but for right now I'm just not going to talk about it, but we do need to know about multiplicities, so make sure that you watch that section in the video. So we know what the end behavior is. We have x-intercepts and y-intercepts. At this point, you can start graphing. So keeping in mind my zeros, negative 3 and negative 5. Negative 3, negative 5, and here's 0. Let's go ahead and plot what we know. And we know that the graph is falling on the left and it's rising on the right. So what I would do at this point is I would take my calculator out, because what we want is we want some additional points. So I might be curious as to what the value is here at -4. So I'm going to show you how I do this in my calculator, and to make work really easy. Alright, everybody can see my calculator. So first thing I'm going to do is I'm just going to do -4, enter. And that's storing -4 in my calculator. It's just storing it. Every calculator has a store function. And then I'm going to go to my expression that I have over here. So we have, I'm going to do second answer to the third. So that A and S is that -4. Sorry, I'm trying to keep that light out of the screen. Then I got to do the 8x squared, so plus 8 times the second answer squared. Then plus 15 times second answer. And we get 4. So a plot of point. And a nice thing about doing it like this in my calculator is all I got to do, let's say we want to do f at -2. All I have to do in my calculator is I just have to go -2, enter, and then I'm going to scroll back up to that line that had the A and S, and now A and S here is going to be the -2. And what do we get? We get a -6. Okay? And then finally we can do one more. F at -1. So again, in my calculator, all I'm going to do is I'm going to do -1, enter, and then I'll just scroll up to where I have my A and S. Again, A and S here, answer is going to be that -1. Hit enter, I get -8. So that's going to be right there. And so now I can get a rough sketch of this graph. It doesn't have to be perfect. And I clearly messed that one up. See if we can do this again. -8. There we go. There's a rough sketch of the graph. So, to sketch these polynomial functions, the big thing that we need to know is end behavior. Do we have opposite end behavior, or do we have same end behavior? And we have to determine what if it's going, like this or like this. Have to find the zeros of the function. If you can do it by factoring, awesome. Sometimes you might have to use synthetic division to find the zeros. Find the y-intercept, same steps that we've always done for the y-intercept. Evaluate the function at 0. Plot your points, plot your known points, and then I always get some additional points. So let's see if we have time for one more. Alright, what are we going to do? Okay. Example 2. This will be all that we get to preview today. Negative x to the third minus a 4x squared minus 4x. Actually, I think I want to change that. Let's change that to let's change that to let's change those exponents to negative x to the fourth, negative 4x to the third, and negative 4x squared. Okay. Alright, so in behavior. So, this is the way I do it in the notes, a sub n x to the n is our negative x to the fourth. So, when we talk about n, our n is the 4. And our a sub n is the negative 1 that we have right there. So, n is equal to 4. A sub n is equal to negative 1. 4 is even. Negative 1 is negative. So if you have an even function, even means it's the same. So we're dealing with same in behavior. And since it's negative, it's going to go point downward. So this means we're dealing with something that looks like this. Again, we don't know oftentimes we'll put a question mark here in the middle. We don't know what it's doing in the middle, but we do know that it's going to fall to the left, and it's going to fall to the right. That's what we know so far. All determined by that leading coefficient. B, what are the zeros? And we're not going to have time to finish this. Already can tell you. I'm going to factor out a negative x squared. That leaves me with an x squared minus 4x minus 4, plus 4. Which then, that becomes x plus 2 quantity squared. So my zeros are x is equal to 0 and x is equal to negative 2. Now, multiplicities. These are repeated zeros because they have exponents with them. So the multiplicities of these two zeros are both 2 and 2. Now, because these are both even, because the multiplicities are even, this is going to tell us something about the graph. The graph is going to touch and turn at these zeros. So, we may be able to wrap this up. C, what is the y-intercept? It is 0. How do I know that? Because I have an x-intercept at 0.
Your conference is scheduled to end in 2 minutes.
So let me talk about those multiplicities. We have x-intercepts at 0, negative 2. So negative 1, negative 2. We know that our graph falls on the left and it falls on the right. Now make sure you watch this in the notes and do the examples that I do in the notes, but anytime that you have a repeated zero an even number of times, it's going to touch and turn at the zero. So this graph is going to come up, it's going to touch and turn, and then it's going to come back up, and it's going to touch and turn at that zero and go down like that. Now, you can verify this by plotting points. If you plot the point -1, at -1, I think you're actually going to get -1. Now, in the last seconds, notice what this graph can't do. Cannot do. This graph cannot come up and then go down, come back up and go down like that. Can't do that. Why? Because there's not a zero there and there's not a zero there. The only places that this graph crosses
Your
the
conference is
x-axis
now over. Goodbye.
or touches the x-axis is at -2 and 0. Alright, so there's a preview. I will see y'all Wednesday. Make sure you watch the notes.